So a circle C has centre 3 minus 1 and radius 2. Write down the equation of circle C. So in your log tables on page number 19, I do believe, you've got x minus h to be squared plus y minus k to be squared is equal to r squared. This fella here, your centre is always known as hk and your radius is 2. So we set it up here and we get setting it all up there, and now subbing in our values for h and k. So h is 3, k is minus 1. Remember my note there, my only tip, if you have negative numbers put in brackets, and the radius there is 2. And to finish this question off then for part A, we get x minus 3 to be squared plus y plus 1 to be squared is equal to 4. One special note on this, so that's that question finished. One special note, you're supposed to recognize that this fella has a centre 0, 0 and radius r. Right, you're supposed to recognize this, centre 0 and radius is equal to r. So for example, what might have happened here one day is somebody came along and said, okay, I've got a circle with centre 0, 0, and then they might have had a radius of 10. And so they started using this formula, and they started seeing that they came across redundant information. So for example, centre 0, 0, so remember I told you h and k there. So now we come along and we say x minus squared plus y minus, so this is just an aside by the way here, and I told you the radius was 10, putting in here 0, 0, 10, and lo and behold, what did you find? Any circle with centre, so x minus 0 is x to be squared, any circle with centre 0, 0 and radius r, but it always had that x squared plus y squared there, and that meant that the centre was always 0, 0. One of these years, the following is going to come up, and maybe it could be this year, you could get 4x squared plus 4y squared is equal to 16, and all of a sudden you're like, oh my god, I've never seen one of these before. Divide by 4, divide by 4, divide by 4, you get that, and now your centre is 0, 0, and your radius, so r squared is equal to 2, your radius squared is equal to 4, and r is equal to 2. Take the square root of this side r, take the square root of this side 2. So just be careful of that. I'm expecting one of these years. The circle C is shown in the coordinate diagram below. The point 0, 0 is also shown and labelled. Yeah, lovely. Then it says circle CS is the image of the circle C by central symmetry to the point 0, 0. So central symmetry basically means that we're going to get the circle drawn somewhere over here, I'd say. So let's map that up. So the easiest way, go up one box, go across 1, 2, 3, and we're going to do the same thing over here. Go up one box and go across 1, 2, 3, and there you can see your new centre is minus 3, 1. So your new centre is minus 3, 1. You can see here that the radius from 3 to 5, so you've got a distance for the radius there of 2. So r is equal to 2. Do the same here, 2 boxes, or I could just do the same thing here, 1 box up, 5 across, 1 box up, 5 across, whatever you want. The radius is 2. Get your compass. Now I'm going to draw a terrible graph. Get your compass here, and you just put the centre here, step out the pointy bit and mark it there and draw your circle then, which mine is going to look absolutely cat, but I'm drawing it completely freehand. So it's down there, sorry, and yeah, it's going to look terrible, but you draw it accurately with your geometry set. So, just to be clear about it though, the centre is minus 3, 1. So that's minus 3, 1 for the centre, and your radius is going to be, as we established there, it's going to be 2. Moving on, hence construct the circle. We've done that. Terrible attempt on mine. Remember, you will have a geometry set and you are expected to draw your circle very accurately. Okay, so again, your key points, put the centre of the circle, the point in the centre there, then push out the compass and just mark that point. You've now got your radius, which is 2 units, and just swing the arc around and it will turn out to be very nice for you. So part B here, the circle K has centre 4 minus 2, you can see that there, and the point B 7 is 7, 2 is on the circle. It's also showing a point of contact, so it's for the tangent line L. So then it says information is shown on the diagram below. Something to note here, if this is the tangent line is perpendicular to a line drawn from the centre to that point of contact. So that point of contact there, that is a 90-degree angle there, and always is the case with the tangent line. From a line drawn from the centre to the point of contact, not POI, point of intersection between the tangent line there. Yeah, well, look, point of intersection if you like, point of contact, whatever, point of intersection. I'm going to run out of road there, or point of contact. Point of contact is a more formal name on it there, I think, between where a tangent line and the point on the circle is. But that line from the centre to that point of contact will always be at right angles to your tangent line. So we are now asked to find the slope of AB. So the easiest way to find the slope of AB is just write down A, which is minus 4 minus 2. Your B is your point, I think it's 7, 2. So now go to your log tables. Your slope formula there is y2 minus y1 over x2 minus x1. If they give us a nice grid up there, I might have used rise over run and that, but look, I want to make sure here you're using algebra, so you could just make mistakes by, you'll probably be sound as well, like. But so you have a choice, maybe. So y1, but I haven't done this in a while, so I'll go back to it. It's in your log tables. This formula here. Set it up. Fill in. Y2 is 2. Y1 is minus 2. Make sure you put in brackets. X2 is 7. And x1 is 4, and now you get your calculator, you fire that into your calculator and you'll get an answer of, looking to me like 2 plus 2 is 4 over 3, and hopefully that's correct, 4 over 3. Now, as I was telling you up here, so the slope of this line here, we'll call it M1 for short. That slope there is 4 over 3. And M2 here, which is the slope of the tangent line, is the fella that we don't know. But we know an absolutely massive fact. We know that two slopes that are perpendicular to each other, when you multiply them together, you get an answer of minus 1. Because we know that, if we know the slope of one of them, which in this case is 4 over 3. Maybe I wrote 3 over 4 up here. No, I wrote 4 over 3. If we know the slope of one of them, to find the slope of the other one, all you do is you flip it upside down and you change its sign. Right? You flip it upside down and you change its sign. That's all you do to find the slope of the other line. So M2 there, slope is minus 3 over 4. I can prove it to you. If you did this here, you would get plus multiplied by minus is minus, top by top is 12, bottom by bottom is 12, minus 12 over 12 is minus 1. 12 over 12 is 1. So there's the slope of our tangent line, minus 3 over 4, and I think that's what you're asked to do in that question. I'll just have a quick double check. The slope of the tangent line is minus 3 over 4. I don't think you're asked to find the equation or anything. Find out the slope of the tangent line, and there you go. Job done. Happy days.